Hello and welcome to this Nordic Tech webinar. Today we'll be talking about the nRF54L series, the next level wireless SoCs from Nordic Semiconductor. My name is Paweł Kanafek. I'm product marketing engineer at Nordic. Sam Presley, technical product manager for nRF54L series, will join for Q&A session to answer your questions about the details of these products. First, let's explore our product portfolio to explain how nRF54L series is positioned among other products and how it complements the portfolio of devices that we have. So these devices can support a broad set of wireless technologies, which includes Bluetooth Low Energy, covering all standard and more optional features, such as custom GATT profiles provided by Nordic, Bluetooth Mesh, periodic advertising with responses, Bluetooth channel sounding, and Bluetooth Low Energy audio supported by nRF53 and nRF54H series. These products also support IEEE 802.15.4 protocols for smart home and industrial applications with networking and mesh protocols like Matter, Thread, or Zigbee. They also accommodate proprietary 2.4 GHz protocols with our ESB Enhanced Shock Burst protocol and allowing for development of any custom protocols. Additionally, they can act as passive NFC tags. The nRF52 series has been our most popular series up to date. It has been introduced several years ago and broadly adopted and manufactured in billions of chips. The 52 series features an ARM Cortex-M4 running at 64 MHz, offering various configurations with different memory sizes and peripheral options. nRF52 series revolutionized the landscape of low-power wireless devices with its level of integration, multiple features available in a single IC, and low power consumption. This was a groundbreaking combination at the time, and it enabled new product categories. Following the 52 series, we introduced more advanced 53 series. With two processors, both are ARM Cortex-M33, the application processor and the network processor running at two different clock speed, and it also provides more memory. 53 series enables uninterrupted execution of more advanced application software and wireless stacks in parallel. nRF54L series is an evolution of the 52 series. It's designed for similar use cases and products, but with more processing power, featuring ARM Cortex-M33, running at twice the clock speed of the 52 series, and additionally it includes a RISC-V coprocessor. nRF54L series takes the nRF52 series to the next level and with improved processing power and significantly lower power consumption. With these features, it is set to enable major improvements of existing products and enable new product categories. The upcoming nRF54H series represents a revolutionary design. The level of improvement there is comparable with what 52 series brought when it was first released. Therefore, 54H series is set to revolutionize the industry and enable new products combining advanced compute capabilities and wireless in a single very small IC. With this portfolio of products, we've achieved a leading position in the market. Over the last 5 years, 40% of all qualified Bluetooth LE products that were registered with Bluetooth SIG were based on Nordic SoCs. We provide a complete solution to ensure efficient product development and high quality. In addition to the SoCs, we offer a suite of wireless protocol stacks included in the nRF Connect SDK. nRF Connect SDK also features a comprehensive set of libraries, drivers, and additional modules for efficient software development. We also provide hardware and software tools helpful in the development, but also mobile application resources and mobile applications available on Google Play and Apple App Store. With most of these mobile applications are open source, available on GitHub. These applications can be reused to develop your custom companion applications for your products. nRF Connect for Mobile is the most popular mobile application. It is valued for its extensive feature set, and it's very highly rated on Google Play Store, and there it has been downloaded over 1 million times. On the side of the support, we are providing educational resources like the Developer Academy, also DevZone, tech support platform with a forum, blogs with development tips and other tech-related articles, and DevZone is open. Therefore, anyone can issue tickets there and get support regardless of the size of the project. We also provide hardware design consultancy and antenna tuning support. Every year we host Nordic Tech Tour, and we also provide Nordic Tech webinars that all are then available offline. Apart from that, we run a partner program with experienced companies that can provide design and solution services. Our goal is to enable the development of exceptional products by providing a comprehensive solution that supports developers from start to finish. Now, let's focus on the nRF54L series SoCs. Currently, we are at the general availability stage, with the nRF54L 15DK available at distributors. This DK features nRF54L 15 and can emulate L10 and L05. The SDK and documentation have been released, and mass production of SoCs will begin later in December. This will make SoCs available at distributors. The series is supported in Dev Academy, and tech support is ready to reply to your questions. Before this stage, we conducted a limited sampling program aimed at accelerating early product development. We expect the first products based on 54L series to hit the market soon, with the program active since October 2023. Over 300 customers participated, and that helped to ensure the product's maturity prior to the release. The feedback received has been helpful in prioritizing software features and ensuring that the mostly needed features are ready and proven. Moving forward, we will continue to enhance the software to meet the upcoming standards and requirements. So expect new features and improvements in the upcoming SDK releases. Let's discuss the chip itself. The nRF54L series, like all our products, is highly integrated to facilitate easy development. The 54L series includes a multi-purpose MCU, radio, security features, memory, a coprocessor, a standard but comprehensive set of peripherals and interfaces, as well as high-speed serial interfaces and GPIOs. This integration simplifies design. You can choose between a QFN package for ease of handling and cost-effective manufacturing, or a CSP package for size-constrained products, as it measures just 2x2 by 2x4 millimeters. There are also modules available. I will cover this in later slide. These features enable the 54L series to be used in a wide range of applications, from consumer electronics to industrial and medical devices. Now let's examine the features of the 54L series in detail, starting with the MCU and memory. The MCU has been upgraded from Cortex-M4 in the 52 series or reached 53 series, which has been upgraded earlier. It also got a doubled clock speed compared to 52 series. It includes Trust Zone, FPU, and DSP, and also a few more extensions that you can find in the datasheet. Memory is the only difference between the L15, L10, and L05, with non-volatile memory ranging from 1.5 to half megabytes and various RAM options. RAM is the technology for non-volatile memory, replacing flash. The nRF54L series provides doubled processing power of the 52 series. This increase is expected given the doubled clock speed, but what's interesting is the efficiency, which has also improved by more than 3 times, enabling more processing capabilities at lower energy cost. Here you can see a comparison of two power profiler traces. This comparison shows the same code executed on both the L15 and 52840. In this comparison, we're running the same piece of code. So on the left, you can see that it took half the time for 54L to complete the task. And also, it consumed way less energy that you can see on the average current and the total charge under this trace. So it proves the more than tripled efficiency of 54L series compared to 52. nRF54L series is equipped with the new ultra-low power 2.4 GHz radio. On the physical layer, it supports Bluetooth, 802.15.4 protocols, proprietary protocols, and gives access also to the PHY for development of custom protocols. It also features new capabilities, such as Bluetooth channel sounding, which is already experimentally supported in the SDK, so we have the implementation in the Bluetooth controller so far. We will be adding support for channel sounding in the upcoming releases. Bluetooth channel sounding is a new feature, providing reliable distance measurements and presence detection. This method is more accurate than those based on RSSI and can be implemented with a single antenna only, so it does not require complex antenna arrays as direction finding, for example. Channel sounding also includes built-in security features, and being standardized provides interoperability between devices, such as location tags and mobile phones and so on. So we can expect an ecosystem of channel sounding based devices to emerge soon. Additionally, there is a 4 megabits per second data rate for proprietary protocols. That's doubled compared to 52 and 53 series, which supported 2 megabits per second. This enhancement enables lower latency for products such as gaming controller or other applications that require higher throughput and quicker responsiveness. So any device that requires a higher throughput than available with standardized protocols can benefit from this feature. The radio also features an output power configuration with 1 dBm resolution in range minus 10 dBm to 8 dBms. In this range, it's with this resolution. And this is particularly useful when fine-tuning the balance between range and power consumption. In the 52 series, it was more discrete at 0, 4, and 8 dBm. In the following slide, we will discuss improvements in power consumption of this radio. But it's worth mentioning that these improvements were achieved with up to 8 dBm TX power that's available on CSP package, and 7 dBm on QFN package. RX sensitivity is at the level of 96 dBm for Bluetooth Low Energy and 101 for 15.4 protocols. In terms of power consumption, the difference is clearly visible. For example, the TX system current, which includes the overall system of the radio and the MCU running the stack, shows substantial improvements. In active TX mode, the improvement ranges between 22% at 0 dBm up to 39% at 8 dBm. The RX system current shows an improvement of almost 50%. Looking at the absolute values found that you can find in the datasheet, the TX system current is significantly lower at peaks. This is an important improvement for devices that cannot handle higher peak currents, such as those powered by coin cell battery. For some products, this could have restricted the output power because of peak currents limitation. This restriction is eased with lower peak currents on nRF54L series. Now we'll move on to online power profiler demo. Majority of you probably already have seen this tool. It can be found on DevZone, and what it does, it presents the power consumption of our devices in various Bluetooth LE scenarios. So here in the menu in the left, you can select the chip, configure it for various parameters, and also select its role and settings in BLE setup. So for the beginning, let's take the very basic and very common use case with advertising in connectable mode at 100 milliseconds interval. There you can see a chart with a performance of the radio with power consumption of the radio in a given state, and also the resulting total average current in this event. So nRF54L15 scores 45 microamps. In comparison, nRF52840 consumes on average 94 microamps. So the improvement is almost 50%. When we switch to advertising with TX only, without receiving, we'll see that the difference is slightly less. Here we have 65 microamps, and 54L15 scores 33. If we reduce the interval, it will become even smaller, and I will explain why. So here we have 129, and here we get 265. So it's not that much smaller, but slightly smaller. The difference is in the execution of switching between RX and TX, where 54L15 performs better than 52840. So you can see that this area here reaches quite high. That's the time when the radio switches. And also there is this start radio event between consecutive TX. So on 54L15, the peak currents are lower here, but this power current consumption is way less while switching, and also this start radio event does not exist here. With online power profiler, you can also switch to connection in different setups, select the configuration that you need, and for this basic configuration with just maintaining the connection, you will see that 54L15 consumes 116 microamps and 52840 over 200 microamps. Alright. The nRF54L series enhances performance and ultra-low power capabilities particularly in processing and wireless communication. These advancements are a result of our unique expertise and innovative design approach. First of all, we're building on the expertise of the 52 series and 53 series. So with this many customers and this market position, we really made it to getting the best expertise in Bluetooth LE. The nRF54L series incorporates new technologies and intellectual property, including proprietary Nordic RAM technology, implementation of low leakage peripherals, and improved power supply and clock management. The architecture has been optimized for low power operation, and nRF54L series includes a new ultra-low power radio design. As the processing capabilities are the key enabler for devices becoming more sophisticated and providing more value to the customers, another objective was to boost the processing power and efficiency of the MCU. We have also transitioned to 22 nanometer process node, enabling significant improvements. These enhancements contribute to longer battery life, allow for more features, and enable greater processing capabilities without sacrificing battery life. Alternatively, they can reduce battery size for smaller, lighter products. But even for mains-powered devices or devices that don't care about the power consumption so much, the ease of use and the design simplification with high level of integration is another factor for using nRF54L series. Let's move back to the features. We'll overview security now. The 54L series meets all current regulatory requirements with features like secure boot, secure firmware updates, secure storage, trusted execution environment enabled by Trust Zone, and it also introduces a new cryptographic engine, Kraken, protected against side channel leakage. It also features a new thing, tamper detectors that can respond to attacks by resetting the device or taking other actions, such as deleting keys. We recently published a Nordic platform security document that offers a comprehensive overview of the security technologies and features implemented across our solution. So this document is an excellent resource for understanding security principles and how particular features are integrated into our products. Next feature is the RISC-V coprocessor. We've seen significant interest in this feature. It really captures a lot of attention, and we are pleased to hear that. The coprocessor available here operates at the same 128 MHz clock as the main processor. And in terms of naming, it's our own implementation of the RISC-V instruction set. So in the documentation, you will look for VPR, RISC-V processor, or its specific implementation in the 54L series, which is FLPR, Fast Lightweight Peripheral Processor. It's designed to handle time-critical tasks when the main processor is busy or preempted by wireless stack-related tasks. And these issues previously often required some workarounds or even an additional MCU on your PCB, for example, to continuously gather sensor data without interruptions. This coprocessor helps to resolve these issues. It supports custom code development. We will also provide libraries for this in the future, and currently it is experimentally supported in SDK 2.8, so development for RISC-V is possible. However, it requires some guidance from our side. If you need to develop with it, please contact us, please contact our sales for more information. We often get one more question, so to clarify, The intention is to run the stack and the major part of the application on the main processor, on the ARM, as it was done on the previous devices. The RISC-V coprocessor is intended as an additional independent processing power to support main processor in some specific use cases. So with the efficiency of ARM Cortex-M33, it's recommended to use it as a default processor for majority of tasks in your software. Regarding peripherals, the nRF54L series features the same set for all parts in the series. So we have 4 serial interfaces with SPI, 2-wire interface, also known as I2C and UART, I2S and PDM for audio handling. PDM is an interface for microphones. Then we have an improved 14 bits ADC. It offers higher resolution than previous devices, and it also enables more frequent readings, up to 2 mega samples per second. Then we have NFC tag, 3 4-channel PWMs, and one more new thing, quite interesting, a global RTC. So this RTC can run in system off. This allows device to sleep and maintain RTC wake-up capability while running at around 800 nanoamps when supplied from 3 volts. That's a major improvement over the 52 series. As we know, some design even used external RTCs to keep Nordic SoC in the lowest sleep mode and to save power consumption of the overall device. With the global RTC, it's much simpler. It also features timers, codec, watchdog timers, temperature sensor, and comparators. On the high-speed side, we have one high-speed serial interface, and the RISC-V coprocessor is also in this area. Why we have these two areas? So low leakage and high speed, because after moving to smaller geometries, to 22 nanometers, leakage currents starts to play more significant role. Therefore, some peripherals are manufactured using specific technologies to ensure that while running on slower clock speeds, the overall device remains ultra low power. Because of that, there is a constraint in connecting specific GPIOs to specific peripherals. In general, peripherals must use pins within the port in the same power domain. That's a small constraint, but on the other side, the overall power consumption of the device is way lower. So on GPIOs, you have up to 21 GPIOs that can be used with low leakage peripherals and 11 GPIOs that can be used with high speed peripherals. Regarding the voltage, although I don't have a specific slide on electrical characteristics, I can mention that the supply voltage and GPIO voltage is supported in range 1.7 to 3.6 volts. And also the device can operate in temperature range of -40 to 105 Celsius. So available package options. We are starting mass production of SoCs now in late 2024. We will begin with the QFN package featuring 31 GPIOs, starting manufacturing in December. And later in March, we'll continue with the chip scale package. Additional packages are planned for later in 2025. We are also working with module manufacturers, or you can say that they work with us. So they do offer plenty of modules based on 52 and 53 series, and 54L series will also be provided in the form of modules. So the modules are upcoming. You can find the list of all modules that will be available on nRF54L product page under the modules tab. There are already multiple options. So why to use modules? So modules reduce design costs. They can have an integrated antenna. They do include external circuitry and also can be pre-certified for CE, FCC, wireless standards, and other industry-specific standards. Some module manufacturers offer additional value or specific features such as dedicated software, additional support, or other enhancements. So it's beneficial to explore the offering of different module vendors to see what they can provide, of course, if you are considering using a module in your design. Some of the modules use the CSP package, so that enables very small modules. We've already seen some modules like way below a square centimeter in area, and I've heard that even smaller modules will be available. Before we move on to other topics, I would like to mention complementary ICs that you could use with the nRF54L 15 series. First, on the power supply side, we have introduced the NPM family, offering power management ICs that integrate several key components typically used in separate ICs. This integration can simplify the design and make devices smaller. Our PMICs provide battery charging, fuel gauge, which is quite accurate thanks to additional software support that runs on the host processor. This fuel gauging consumes less power than Coulomb counters, for example, but provides comparable accuracy. A system-level watchdog built-in hardware reset that can trigger a hardware reset by toggling the power supply, and this can be triggered by a button that is directly connected to PMIC. It features power loss warning capabilities that can activate earlier than the brownout detector of 54L. That's because PMIC is implemented before decoupling capacitors. It also includes a few additional GPIOs or LED drivers, which are particularly useful for designs where the wireless SoC is supplied from 1.8 volts, for example. They are also USB-C compatible. So if you're a software developer and your colleagues from hardware department are not here, let them know about it. On the antenna side, we are providing front-end modules to extend the range and improve reliability with higher TX power up to 20 dBm. nRF54L devices are currently supported with the latest nRF Connect SDK. So I won't spend much time here as we have plenty of resources about the nRF Connect SDK. That includes a few webinars and other resources that I will mention later. I will just do a quick overview of the nRF Connect SDK with a focus on features supported by nRF54L series. So let's take a look at the example for Bluetooth Low Energy. You can see that the majority of software that we are providing is provided as source. Only some specific components are provided as binary. And starting from the bottom, there are plenty of drivers for components of our chips. Of course, they're fully supported. But with nRF Connect SDK, through Zephyr, you get access to plenty of drivers for external sensors, other ICs, displays, and many other devices that can be reused in your project with ease. On the Bluetooth stack side, we have soft device controller that's provided by Nordic, and this component is known for its great interoperability with third-party devices on Bluetooth Low Energy. Bluetooth host is included in the Zephyr project, so we are contributing a lot to that host, and we are upstreaming the code that we developed to Zephyr project. nRF Connect SDK includes Zephyr RTOS, so you get a scheduler and all other RTOS features. There is also middleware, libraries, and selection of samples presenting usage of features such as basic advertising, connections, and other features related to peripherals, and many more. There are also more advanced examples of software that we call applications that include more features such as DFU, security, so they are more complete and specific application-oriented examples that can also be reused. So with this SDK, you can select the low-level functionalities you need and build your application on top to focus on product differentiation, to reduce the time to market, reduce lifecycle maintenance cost by using the upcoming releases of nRF Connect SDK and DFU capabilities that comes with these wireless protocols. And also, even though this SDK may look complex in this diagram, it's possible to start with a very simple sample-based project. And if your application is simple, just keep it there, add only a few features, and your software can be delivered. nRF Connect SDK also includes stacks for ecosystems such as Matter or Sidewalk. It also supports Google Find My Device and Apple Find My. nRF54L15 is capable of running Wi-Fi stack for nRF70 series that are companion ICs with Wi-Fi radio. Along with the SDK, we provide an extension for VS Code, the nRF Connect for VS Code. It's a comprehensive extension for VS Code built from the ground up for nRF Connect SDK and our devices. That includes a set of tools and features for development. It provides command line interfaces, GUI interfaces for development, such as Device Tree Visual Editor that you can see on the screen right here in the right. With this editor, you can configure the hardware with this GUI for your custom boards. This extension also contains debugging features, memory report built-in terminal, nRF kconfig, and this extension also supports SDK and toolchain manager, so you can install and manage the version that you're using directly in VS Code. nRF Connect for Desktop is another application that includes a few hardware and software tools for development. So it includes, for example, Bluetooth Low Energy application. That is a general tool for development and testing with Bluetooth Low Energy. So it can emulate a peer device for the product that you're working on. Board configurator for new Nordic development kits. Power profiler for Power Profiler kits. I presented the screenshots from that before while comparing processing efficiency, a programmer for flashing hex files on your devices, and Quick Start that I will cover in a few slides. So how to get started? First, what you will definitely need is the development kit. The DK first and foremost features the nRF54L15. This DK can emulate L10 and L05 by restricting the available memory amount. This emulation is currently supported as an experimental feature, so we are recommending developing for L15 target now, but with the upcoming releases it will be fully supported. The difference is only the memory size, so as long as you keep your application within memory restrictions of L10 or LO5, you should be fine with moving on to L10 or LO5 later on. This DK also features 8 MB of external memory, buttons, a connector for RF measurements, LEDs, a connector for an NFC antenna. The antenna is included in the kit, pins for current measurement, onboard debugger, and a few more essential features needed for development. We have also changed the USB connector to more modern USB-C. There is also NPM 1300, you can see it here. This provides a power supply to 54L15 and the entire board, and it's controlled by the DK board controller. On the DK page, you will find the widget with a list of distributors that have the DK in stock. This DK is way simpler than our previous DKs, as you saw. That's because it's software configurable. The board configurator can configure features of this DK. So you just connect it, it will detect the board that you have on your desk, and then you can configure it and write the config onto it. With this application, you can connect or disconnect virtual COM ports, enable or disable LEDs, so you can measure power consumption without LEDs, without playing with code. It has a switch for disabling the onboard debugger to use the external one, and it also controls the VDD voltage provided from PMIC in range from 1.8 to 3.3 volts. So there are a few ways you can start even without the DK. I will describe them in more detail in a moment. So these are Dev Academy, a quick start application, and YouTube playlists. First, Developer Academy. That's the most time consuming, but the most in-depth and most valuable way to discover nRF54L15. In the beginning, if you haven't worked with nRF Connect SDK or Nordic, you will want to go to nRF Connect Fundamentals for the basics of the tools and getting started with Nordic solutions. Then you have Bluetooth LE Fundamentals with a recap of knowledge about Bluetooth Low Energy and a step-by-step guide for developing a simple Bluetooth LE applications, working with mobile applications, and, for example, using nRF52840 dongle as a sniffer. Then there is nRF Connect SDK Intermediate. It is marked in the dashed line because at the moment the nRF54L series is not supported yet. However, we are working on adding it, and we will inform you about it in the newsletter, as it will happen quite soon. A quick start is another way to get started. This application, as you saw, is within the nRF Connect for desktop, and after you get the DK and connect it to Quick Start, it will guide you step by step through the process of setting it up, testing that it works, and onboarding to VS Code. So in the first steps, you'll get an info about the connected DK, then you'll be able to rename it so you don't mix up your DKs, and this specific DK will be then detected by this name in your tools on your PC. And in the later step, you will be able to program it with a selected precompiled application like Hello World, LBS service, or Nordic UART service. Then this application will guide you on how to verify that the software flashed on the board works correctly. I've selected LED button service. as sample, and for this one, in the evaluate step, you will get an instruction on how to connect nRF Connect for mobile and how to toggle the LED and how to get a notification about the state of the button in the nRF Connect mobile application. Then it gives a few links to learning resources and guides you through the process of setting up nRF Connect within VS Code. So after that, you will be able to set up, for example, one of these samples, get a code of them, get a project of VS Code, and play with a few simple things to make sure that your setup and toolchain works correctly, like changing the LED that is blinking or changing the UART message, and then you will be ready to go. In the end, this app will check that you have all desktop tools installed that can be useful, and from now on you can play with your own stuff. But if you don't have a DK and still are eager to learn more about the NCS right away, there are two playlists on YouTube that I can recommend. The first one is nRF Connect for VS Code tutorials. You can see that these are quite short videos, a few minutes each, but going through the basic topics related to working with Nordic solutions. And there is one more in-depth playlist. These videos are about 20 minutes long, more in-depth look into prototyping with nRF Connect SDK, adding sensors, working with Bluetooth Low Energy, storing data on non-volatile memory, using Power Profiler Kit, or adding FOTA over Bluetooth. So quite comprehensive guide. So we are arriving at the end of the presentation. I didn't have time to dive deeper into the technologies or give a hands-on demo, but of course there are places that you can find more information. So the hardware is not everything, I know. So for sure, for your projects, you will want to take a look at what wireless features are supported, how they perform, what do we have in the stacks. So for that, you may want to go to nordicsemi.com, and then in wireless section, you will find more information about all technologies supported for 54L, such as Bluetooth Low Energy, Bluetooth Mesh, Thread Zigbee, or proprietary protocols. And then you also have technologies, landing space, and then you will find information about supported ecosystems and other solutions such as Matter, Amazon Sidewalk, and Apple Find My, Google Find My, and so on. So thank you very much for your attention so far. Now we will proceed to the Q&A session. So let's just turn on our cameras. Sam, are you ready to take questions? Yeah, nice.
Yeah, let's go.
Okay, there are plenty of great questions. We'll do our best to answer as many as possible, and we'll be wrapping up at the top of the hour. So the first one, Sam, for you.
Yeah, so the current consumption of the ARM Cortex, so you'll see we set the number at 128 megahertz, and that's because we only support execution at 128 megahertz from this CPU at this point in time. And the approach here is to execute code quickly and return to the sleep modes as quick as possible. And we find that using the CPU in this way results in the lowest average power consumption for most use cases.
Next question about Nordic distance measurement toolbox. So currently, NDT is not supported on 54L series. However, channel sounding is a great technology, so you can check the product page for channel sounding. It's in the Bluetooth Low Energy landing page at nordicsemi.com. you can check if it works for you. If it doesn't, let us know on DevZone, and we'll see how we can help.
Okay, I'll take this one regarding the memory. So in the nRF54L15, we have RRAM as the non-volatile memory technology. So in general, this is quite similar to Flash in many ways. The main significant difference is that it's possible to overwrite RAM without having to do an erase first, which you have to do with Flash. The read and write times are fairly similar compared to Flash. The write times are slightly longer for RRAM, but this becomes not significant when you consider the benefit of not needing to do the arrays before the write. And in terms of the endurance, it has similar endurance to Flash, so around 10,000 writes.
Okay, and it will be a series of questions to you, Sam, now. First one about using Wi-Fi.
Yeah, so regarding comparing the 54L with the nRF53, so the processing efficiency of the 54L is improved compared to the 53 series. So if you're doing a lot of processing in your application, it may be that there is a power consumption benefit using the 54L compared with the 53. So really this would, you'd need to analyze this on a use case by use case basis to see if there's a power consumption benefit for you. nRF52 series. So we think some customers will continue to choose some of the smallest 52 series devices, such as the nRF52805, for applications where very little memory and very little resources are needed. Also, if you need some peripherals that we don't yet support and have available in the 54L series, such as USB, then nRF52 series will remain a good choice until we have that support in this series as well. And I'd just like to say that, you know, the 52 series is a series that we will continue to support for a number of years, and you should not be afraid of starting new designs on these devices.
Yeah, and you have explained differences between Flash and RAM, but there is a question about what RRAM is.
Yeah, so RRAM is resistive random access memory, but this is a non-volatile memory technology. And the reason we use RRAM is because Flash is not available in the 22 nanometer process nodes that we're now manufacturing these devices. And RRAM is the technology that is available in the 22 nanometer process node. And this replaces Flash essentially. If you want to know more about how RRAM works, I suggest there's a lot of resources on the internet you can take a look at.
Now a series of questions about channel sounding, so I will take them. First, about this presence detection. So we say that it either ranges or measures distance or enables presence detection. That's a term reused from beacons that are based on RSSI. So they were basically not able to measure a distance, but detect the presence, whether a person or a device is in range or in close proximity to one to another. With channel sounding, it's possible by measuring the distance between devices. So the same data input, but in the application context, it just plays a different role. So, for example, for a smart lock, you want to be sure that the person is or the device is in a close enough to unlock something. Another question about accuracy of channel sounding. So it's designed for devices such as locks, find my tags, and so on. So like accuracy in range of 0.5 meter is the achievable accuracy in usable applications. Of course, it depends on specific configuration of the device, specific the configuration of channel sounding itself. Even lower accuracy can be achieved, but it's designed for this type of devices. So I hope that it gives an overview. Are channel sounding samples available in the SDK? Currently not. We have experimental support on the controller layer, but we'll be rolling in more support for channel sounding in upcoming SDKs, including samples. Another question that has been partially answered in the slide, but maybe you can give a hint about FPUs.
Yeah, sure. So there isn't an FPU within the Flipper core. And as Pavel said, I think after this question was asked, we gave a bit more information. But the main purpose of the RISC-V coprocessor is to execute timing critical tasks alongside the ARM Cortex. The ARM Cortex is needing to service in the single core architectures like we had in the 52 series. The ARM core is running the radio as well as your application. And what we found is there are some use cases where timing critical tasks also need to be done alongside the radio. And that's why we've implemented this RISC-V core here. So we will be providing some reference implementations of some things that we think this RISC-V core can be really useful for. One example is Quad SPI. That will be coming early next year. And we'll also be giving this to you as a reference for you to be able to implement your own software-defined peripherals.
Next one about global RTC.
Yeah, so the global RTC, so it can be used to track actual date and time. However, you just need to be aware of the conditions where the GRTC gets reset. So these are when the pin reset occurs or if the watchdog timer triggers.
Next one.
Yeah, the ADC. So we have an improved ADC in the 54L. And it supports, so it's up to 14 bits resolution, and this is across 8 channels, and there are 8 pins on the device which can support analog operation. The RISC-V core is connected to the main bus in the system, and it has access to both the RAM and the non-volatile memory, the RRAM. So regarding the compiler, so this will be provided through the nRF Connect SDK and will be a RISC-V compiler, which is already present in the Zephyr toolchain.
About NPMs, NPM 1300 features 2 DC-DC regulators and 2 LDOs. However, I'm not an expert on PMICs, so it's better to consult the datasheet or the product page for it.
Okay, so our strategy on obsolescence and longevity. So if you take a look at our website or just do a quick search for our long-term parts availability statement, you'll find what we say publicly about this. So basically, the summary here is that so long as we receive orders for devices, we continue to manufacture them unless circumstances outside of our control prevent us from doing that. And we're manufacturing devices which we launched many years ago, prior to the 52 and even prior to the 51 series. So you should not be worried about devices which are Nordic devices which are widely used in many applications being obsoleted.
Another question about LE audio. So yes, 54H is recommended for LE audio application, but also we have 5340 that also supports and is intended for Bluetooth Low Energy audio. And there are already products supporting LE audio based on 5340. And I think it will be the last questions as we're at the top of the hour. The SDK is available. Version 2.8 supports 54L series and 54L 15DK, so it's ready for development. Next question, can nRF 7002 be used with 54L15? Yes, it can. Due to memory restrictions, only 54L15 is capable of supporting 70 series. Can you elaborate more about the antenna tuning support? Yes, we mean output network matching. Our tech support is ready to accept such requests. Please reach out to them prior to sending your hardware to make sure that they can do this, but yes, it's possible. Where can I find examples of channel sounding? Channel sounding is currently supported only on the controller layer. Therefore, we don't have samples yet, but these samples will be provided once we will have more support for channel sounding in the upcoming releases. Yeah, so channel sounding is meant not for precise measurements, but for reliable presence detection or coarse measurements. By coarse, I mean the range of like half a meter, for example. So the goal is to make the technology is made, for example, for logs or for asset tracking tags. So with channel sounding, you can figure out whether your keys are under the cushion on your sofa on the right or on the left, or whether you're really close to the lock to enable unlocking it. So regarding connection requirements for channel sounding, yes, two devices need to be connected. So secure ACL channel needs to be established first to perform the measurement. Therefore, this technology is not meant for like mass measurement of multiple devices. It's more for device to device scenarios. Yeah, so with that, I have answered the following question, so I won't be displaying it. Yeah, and Sam, question to you.
Yeah, so question of whether the 5840 can be replaced with the 54L without changing a PCB. So a new hardware design is required for designs targeting the 54L series. However, the important thing to know here is that once you've done that hardware design for the 54L in the QFN package, the 54L15, the 54L10, and the 54L05 are all pin-to-pin compatible with each other. So whilst this effort does need to be made to move from the 5840 to the 54L, you do have that pin compatibility later. And also, we do offer free design reviews of your new hardware design. So please take advantage of that from us when you come to doing your design. Yep, so on the RISC-V Flipper core, so we will provide examples of using the RISC-V core. And one example of this will be the quad SPI that's mentioned in the question. So you can expect that to be available within nRF Connect SDK in a future release. We're currently working on building up the full development environment to make it easy to develop for this RISC-V core. And you can expect building, flashing, and everything to be supported within the SDK and the VS Code environment in the future. And these examples can also be used as a reference for customers that are looking to implement their own custom software-defined peripherals as well.
And the following one?
Yep, so on power supply for GRTC, so the GRTC uses the main system power supply. So in order to use the global RTC in system off, it's necessary to have power supply to VDD.
Oh, sorry. The window disappeared from my screen. The following question, what does it mean that PMIC is USB-C compatible? It means that it supports CC pins, and it can negotiate power supply with the source. So PMIC is capable of this process. Sam, can you answer the question about Bluetooth qualification?
Yep, so we're currently going through the final stages of getting the Bluetooth QDID for 54L15, and we expect that to be available in the next few weeks before the end of the year. And that will be qualified to Bluetooth 6.0.
And the question about datasheet update?
Yeah, datasheet update. So we will have a datasheet update in December, and there will be some datasheet updates also in the new year.
So a question about pin-to-pin compatibility within the series. So yes, QFN packages are pin-to-pin compatible. So currently there is 54L15, as I said in the presentation. So it's easy to start development on L15, and swapping to smaller parts later on in the process to other QFN packages of these should be swift. Sam, a question about the limit in power output.
Yeah, I can answer this one. So there is a difference in the maximum output power of the QFN and the CSP package. So you'll see that the CSP is a max output of 8 dBm, whilst the QFN is a max output of 7 dBm. The reason for this is that there is some inherent loss of RF power within the QFN package, which is the reason for this difference. So the max achievable on the QFN is 7. It isn't that it's unsafe to set it higher than that.
And the following question.
Yep, the requirements for the crystals, this should be included in the next datasheet update.
Okay, so there are a few more questions. We are already on time, but I think we can take 3 more. Can you see the question, Sam?
Yep. So that we support today the full GPIO supply range from 1.7 to 3.6 volts within the current version of the SDK.
Perfect. And next nRF SDK release.
There'll be an SDK release before the end of the year.
Okay, and I think we'll wrap up here as we are on time. To everyone who posted your questions but we couldn't answer because of not enough time, we will try to reach out to you and answer these questions.
Thank you all for joining.
Thank you all. It was great to have you here, and we wish you a great time exploring 54L series.